Well, we're going to continue on with a lot of the similar topics that we've been discussing with vectors. However, we're not going to take our concepts that we learned with vectors and use them with vectors again. We're going to take those same concepts and basically apply them in the context of complex numbers. Now, a complex number is any number that's written in the form of a plus bi, where a is the real part that tells you how far to go left and right on your axes, and b is the imaginary number, which tells you how far to go up and down on your axes. Now, just like on with normal numbers, absolute value is distance from 0 on your number line, while complex numbers, your absolute value is distance from the origin on your complex plane. Well, let's go ahead and start with this first number here. We have 4 minus 3i. So to graph that, we're going to go right 4 units and down 3 units. Because the real part is 4, tells you how far to go left and right. The imaginary is negative 3, tells you how far to go up and down. Well, your absolute value then is just distance from 0 on your number line. Well, that's this red distance that we're looking for. If you're 4 units to the right, 3 units down, you could form yourself a right triangle. Then you could use your Pythagorean theorem of 4 squared plus 3 squared gives you 25. Take your square root, tells you the length of your hypotenuse. Length of your hypotenuse is your distance from 0, or the absolute value of that number. Now there's different ways we can represent complex numbers. One of them is the rectangular form, the a plus bi. One of them is the trig form, as in r, and then in parentheses cosine theta plus I sine theta. Sometimes that's abbreviated as RCIS. R, C for cosine, I for your imaginary number, S for your sine. Now, in this form, R is basically the absolute value of your number, how far you are from the origin. And then theta is the angle that you are from standard position. Now, for the most part, there's two ways to get to a location. This one here tells you how far to go left and right, and then how far up and down to go. You can get to that same location by going at a certain angle, which is theta, and going a set distance, which is r. Now, a third way you could go ahead and represent a complex number is in the exponential form. It's r times the natural number e raised to the e time, or I times theta. Just be aware that that form exists, but we're not really going to be using that form much in class. So let's go ahead and take our rectangular form here and put it in trig form. For the most part, I find it easiest to go ahead and graph this. Negative 2 tells you to go 2 units to the left. Positive 2i tells you to go 2 units up. So technically speaking, we're just dealing with a dot that's up here. But for the trying to figure out your trig form, it's going to be easier to go ahead and form a triangle. Remember, you always form a triangle coming out from the origin, always going to the x-axis. Your angle is always in your triangle at the origin. And then this is r right here. Well, how do you figure out r? Well, you got to use your Pythagorean theorem. This side squared plus that side squared equals your hypotenuse squared. And then it simplifies down to be the square root of 8, which is 2 root 2. And then we need to go ahead and find your angle. Well, your angle here is just tangent of your angle because we have our opposite, which is 2, over your adjacent of negative 2. So you get tangent of your angle being negative 1. Well, that's one you're supposed to have memorized, so when you go ahead and work that out, you should be able to just pull that off the top of your head and realize that that's 3 pi over 4. If you want to use degrees, you could, but most of the time we're going to be using radians, but not always. So our trig form of our number is r, which we have is 2 root 2, and then cosine of your angle, plus I sine of your angle. So the trig version of the number that we started with is given to you down here. So this is your rectangular version of the same number that you have down here in trig form. Well, if we can go from rectangular to trig, we should also be able to do the reverse process. The reverse process is really a little bit easier. Now, you guys should know what the cosine of 5 pi over 6 is. And you should know what the sine of 5 pi over 6 is, because those are ones you're supposed to have memorized. Well, you go 4. The cosine of your 5 pi over 6 is right here. Then we need to go plus an I times the sine of your 5 pi over 6. The sine of 5 pi over 6 is right here. So all we do at this point is distribute you through your 4, take your 4 through to each one of these, and then we get our answer, and we end up getting 2 root 3 plus 2i. Well, we can also multiply complex numbers together when they are in the trig form. If you're multiplying complex numbers in the trig form, here's your two complex numbers at the top. Your first one here with all subscripts 1, your second one with all the subscripts 2. If you're multiplying your two complex numbers together, it says multiply the two r's together and add your two angles. When you are dividing your complex numbers, divide your two r's and then just subtract your angles. So we want to go ahead and use those formulas to multiply these two numbers together and then divide these two numbers. Notice we're looking for our answer in trig form. This is abbreviation of your trig form, and this is your rectangular form. Well, when it's in trig form, to multiply them, it says just multiply your two r's. So you've got to take the 8 times the 6, and so then we get a 48. Then we got to take and add your two angles, the 120 and the 150, and so then we get a 270. And you do the same thing for your sine. You add the two angles. So then you get sine of 250 or 270. So here's your trig form. Well, we also need to get the rectangular form. The rectangular form, once again, basically you want to evaluate the cosine of 270 and the sine of 270. And so we're going to get a 48 times this, what is the cosine of 270 and the sine of 270 with an I, distribute through, and now we get our rectangular form. We want to do something very similar for our dividing. Dividing your complex numbers, our rules say to go ahead and divide your two r's. So we get 8 over 6, which reduces down to 4/3. And then it says you want to go ahead and subtract your angles. So you get a 120 minus a 150 for your angles. Well, that gives you a negative 30 degrees here. So now we have our trig form. Once again, we need to be not just getting the trig form, but also the rectangular form. So evaluate the cosine of negative 30 and sine of negative 30. And now distribute through. Multiply your 4/3 through to each fraction, and then you get your rectangular form.